Hello everyone. My name is Karthik Bharathatte. I am a second year electrical engineering student of Karmavir Baburao Ganpatrao Thakre College of Engineering, Nashik. Today I am going to present my topic, classification of nuclear reactors. Before that, we should know some basics of a nuclear power plant. Let's see the some basics of nuclear power plant. Here is the some basics. What is the actually nuclear power? Actually, nuclear power plant is a nuclear power plants converts nuclear power plant is a power plant which converts the nuclear energy into electrical energy. Now you may wonder how it exactly converts the nuclear energy into electrical energy. It's this process is quite simple if we see it step by step, understand it step by step. What happened in a nuclear power plant? There is a reactor. In the reactor, the nuclear fission takes place. Because of nuclear fission, there is a large amount of heat is produced. Then uh, this heat is transferred to the steam system. Uh, in steam system, water is uh, converted into steam, high pressure steam. Then that steam is passed through the turbine. Then the turbine is connected to the generator. So as the turbine rotate, the generator also rotate and produce the electricity. So now we see the some principal and major components. So the principle is the control splitting of a nuclear atomic nuclei. During nuclear fission, atomic nuclei split in a very large amount that cause the large amount of heat production. So then So then, the, so then that heat is harnessed and ultimately used for the electricity generation. So here are some components, several components is used in that reaction. So here is the nuclear fuel. So this nuclear fuel is the uh, this nuclear fuel is provides the material which is provides the material for a nuclear fission. Then there is a control rod. So that control rods are there to control the nuclear reaction in the reactor. Then there is a moderator. So moderator is used as a controlling system of neutrons that controls the neutron speed, basically neutron speed. Then there is a coolant. Coolant coolant transfer the heat which is generated in reactor to the system. So this is the whole chain. Then we here the layout and working of nuclear power plant. So we can understand it in a five step. So in the first step there is a nuclear fission happens takes place in the reactor. So this is the step one. Then step two, that the heat generated is transferred to the steam system. In the step 3, that heat is used using that heat, water is heated to the very high temperature, that the water becomes the water becomes the steam, and then that steam is transferred to that pipe we can see here. That steam is transferred to the turbine, which is connected to the generator. So as the turbine rotates, generator start producing electricity. So now we comes to our main topic, which is the nuclear reactor. So there are different type of reactors, and their working is also different. So that's why that are classified into different types. So different types of reactor work differently. So designs, that's why its design are very uh, different. So nuclear reactors are where controlled nuclear reaction occurs, as we seen in the previous slides. Reactor designs governs how heat is produced and removed. So basically, it is do the work of heat management. Then reactor types differ in their operating characteristic. So as the uh, types reactor types change, their characteristics also changes. So classification reactor helps us to understand design and their operations. So this so now we can come on the topic classification by neutron energy. So two principal reactors families based on the energy of neutrons that sustain the chain reaction. So the thermal reactor and fast reactors are the two types. So the thermal reactor is work by using a slow neutrons that typically use moderators. It's efficient for sustained chain reaction and suited for a proven stable operation. Then fast reactor. Fast reactor use the fast neutrons, usually no moderator. It is a high potential for a fuel utilization and enable compact core design. So it has a enable compact core design. Then there is a other classification basis. So as we seen in the previous slide, there is a moderator, coolant, and purpose different types. So in a moderator, light water, heavy water, and graphite categories are categories comes. Then in a coolants, water, gas, liquids, metal, and in purpose, power reactors, research reactors, and specialized reactors are there. So this is the advantages, applications, and limitations of a nuclear nuclear reactors. So application nuclear reactors are used in electricity generation, then research and specialized nuclear uses. So advantages of nuclear reactors are it is a high energy output per fuel unit, then suitable for a continuous power supply, then there are some limitations too. So first limitation is a we need a complex plant design, then strict safety and requirement. Because of its nuclear, there is a very high safety and security is needed. So that's why nuclear waste management and also waste management challenges. So nuclear waste is also uh, very hazardous. That's why it's very safely managed. We should manage it safely. So, as a conclusion, I conclude my topics as nuclear power plants convert the nuclear energy into electricity. Then reactors are classified by neutron energy, moderator, coolant, and by purpose. So then thermal and fast reactors are the primary neutron energy categorized. Then classification help us to understand reactor design and operation. Thank you.